Hey everyone, thanks for coming in. And for those of you that are slowly trickling in here, my name is Nitin Kumar. I'm a senior leader in the technical marketing team in security, so we cover obviously a lot of different offerings, including our cloud security offering, mainly Cisco Secure Access, Umbrella, Secure Web Appliance, and some other products as well. And as you can see from the title, we're going to be digging into understanding not just where your data can end up if the right guardrails are not in place, but also going a few steps back and looking at how you can create workflows in order to secure application usage and understand application usage. And that's really the first step, is start from discovery, and then you can kind of work your way through overall setting a posture for application and data security. So we're going to go through a couple of different workflows. We have a few different demos for you as well to show you what it looks like in the product and how you can kind of build these workflows as you work within the product. As with any session, if you've been to a couple sessions this morning, there is a Cisco WebEx app. The information's here. So if you want to pop in questions either during or after this session, you're more than welcome to, and then I'll answer them as we wrap up. If there's time left over, we can probably open it up for Q&A. If not, you guys can approach me at the end. I think there's a buffer of like 15 minutes between sessions. All right? So this is the general agenda for what we're going to be talking about today, starting with a general overview of secure access and then getting into the specific use cases around discovering applications, how to enforce application usage, how to prevent data leakage, and then talking about some of the other emerging technologies that we've embedded into secure access, specifically around generative AI, which is sort of blown up in the last few years in terms of companies trying to understand what to do with generative AI. Do they allow it? Do they block it? Do you have a security posture for that today? So we'll talk about that, and then we'll talk about another component of secure access to wrap it up, which is called cloud malware, really around cloud continuous file usage and understanding the potentially malicious files that live inside of your environment. Just by a show of hands, are there secure access customers here or umbrella customers? So a few? More than a few? So for those of you that are in a POC, actively testing secure access or umbrella today, or just starting out and getting a demo and understanding what it is, I'll give a really quick overview of secure access. Just know that for those of you that are also umbrella customers or in this transition mode, secure access is an evolution of what we call, it's an evolution of umbrella. And essentially what we've taken is a lot of the security stack that you know from the umbrella product, which is proxy, DLP and CASB, DNS security, firewall, and we've layered that and paired it with this entire solution built around private access. And the foundation of that is really ZTNA and VPN as a service, which is what we view as a differentiator for us at Cisco. So at the top, you can see some of the core services that are sort of layered inside of this product. I mentioned proxy, DLP, CASB, ZTNA. We've included IPS, not just for our internet access flows, but also for private resource traffic as well. So there's another security layer as your users are trying to access your private resources. And then the bottom stuff is sort of the complementary additional security capabilities that you get, including things like VPN as a service, specifically to kind of shore up your legacy applications that you may not be able to protect with ZTNA. And that's why we call it a differentiator, because we're now offering VPN as a service, uplifting that VPN architecture from you to us, and then your user behavior really doesn't have to change too much. And all of this is obviously delivered through a single client. We also have integrations, like you see in the bottom there, with SD-WAN, and then some other platforms at Cisco like XDR, et cetera. So that's secure access. Think of it as a platform more than a product, but we do sell it as a single SKU, single subscription for those customers that are already purchased. You're very familiar with that aspect of it. So what we're going to be focusing on for this presentation is a couple of different technology aspects around proxy. This is the driving engine for our inline DLP, which I'll talk about. Obviously, CASB DLP is the bulk of this presentation. Multi-mode DLP is really the offering name for what we include inside of the product, which is inline and SaaS API, or API-based DLP, or out-of-band DLP is what you might hear some vendors call it. And then lastly, we'll talk about some of the additional capabilities you get around browser isolation and how that's paired with DLP. So one of the things we introduced was the ability to inspect inside of an isolated browser session and then do DLP inspection there. And I'll talk about why that's relevant and how you can use this DLP and browser isolation together to enable safe usage of applications and also be assured that as users are moving data around, that it's not only isolated and you're protected, but we can also inspect that traffic as well. So these are all of the things we'll talk about. There's some newer capabilities that were just released as recent as a few weeks ago around CASB and DLP that I'll also bring up in this conversation too. So the first thing you want to do is start at discovery, and that's something we always talk to our customers about. You may have heard us talk to you directly about is if you already have a posture for DLP, some of our customers come to us and say, look, we have a mandate by our CTO office, or CISO office, to implement DLP. But if we take a step further, the most efficient route to get to that end state of just overall data protection is trying to limit the applications that are risky from running in your environment, right? And the way we do that, just like with any systemic issue, technology or not, is to be able to prevent those bad things from happening, right? And that's really what we're talking about, from a discovery and app protection standpoint. And then once your application is discovered, you start assessing risk, then you can go one level deeper, peel that onion, and get to the data layer and start looking at individual file levels and repository levels inside of Microsoft 365, Slack, ServiceNow, and then start creating DLP policy. And the last part is, once you've done all of this work, is how do you enable safe usage for those applications that may be approved or are in a category that are sort of nascent, and you say, look, I don't want to hinder my employees from getting to applications that they need to, but how do I protect myself as an organization? And this is where we can put in guardrails to enforce safe usage of those apps. And the last part is, once you understand all of the risk, you've built your policy, do you have a view of any malicious content that already lives inside of your repositories, like a OneDrive, SharePoint, Google Drive, et cetera? So we'll talk about that and how you can implement ways on protecting yourself from that standpoint. And that really gives you a holistic sort of coverage from an app and data perspective. So for those of you that have come from the umbrella world or are familiar with application discovery, this is really where our starting point needs to be, is getting visibility into every single application that your users are accessing or have accessed or are currently using. So this dashboard inside of Secure Access is called the App Discovery Dashboard. And really what we're trying to do is help you visualize what we call shadow IT, which is essentially applications that your users are using, but you may not have visibility to. Without this product, you're going to have a combination of a few different things to be able to get this level of telemetry to understand what my users are actually accessing and what the risk is to those applications. And that's exactly what we're talking about in sort of the next few slides here is, once you go through your workflow, determine what negative impacts I may have from a productivity standpoint, from a security standpoint, then you can determine and start creating baseline policy on what applications to allow, right? So our default posture for a lot of our customers is, let's block, and then we'll start to open things up. At the most restrictive, some customers take the opposite approach and say, we're going to monitor everything, but then we want to rein in access based on the risk that we identify. So that's what some of the workflows we'll go through today. And then one of the newer things we've introduced, I think about a year ago, was as customers for you to have the ability to override a risk score. So Cisco has a number of different ways where we can derive the risk score for a given application. But you can go in and just say, look, I don't agree with Cisco's score, or my posture and my appetite for a particular application is going to be different than every other company out there. So you have the ability now to override the risk score. So that's one aspect. The second aspect is you now also have the ability to view what we call the CSR, or community risk score. So if you have 10 admins in your console that have access to this portion of the dashboard, and they're going in and adjusting risk over time, you will see an aggregate score which is essentially a median score of all of those admins changing the risk over time. And then you can use that to infer and make decisions on whether this application should still be allowed or not, right? And if you have 10 admins, we'll take the median score and then we'll present another score there. But as the weights and risk changes over time, that won't change. So you'll still see the weighted risk be adjusted as users are changing, but the CSR will be another variable or attribute that you can use to determine what's good or bad. Now, this is a newer feature. I think we released this a few weeks ago, less than I think 4 weeks, is the ability to take these risky applications and apply them inside of an access policy. So this was a longstanding feature request from a lot of our customers to say, it's great that you guys are able to provide us a risk score. And there's a workflow to attach an application or a category to an existing policy. But what if I wanted to create a policy just based on the risk for a group or a single application? And that's what we're doing here. So we're saying, take the data that we've given you based on the different attributes that make up risk that I'll talk about, business risk, usage type, web reputation, and you can configure each of those settings and then create an application risk profile and then attach that profile to an existing access policy. So it's a pretty seamless workflow. It takes a few minutes to set up. The other thing you can do with the app risk profile is make it a mandatory option inside of an internet access policy. So we do a number of checks, right? Does the user match? Does the source match? Does the destination match? And there's a couple of other options that you can configure, like security, for example. If this request is for a malicious file, if it's for something that matches C2C traffic, then we want to block it. This could be another required attribute where you toggle it and say, I also want to make this an and condition in my policy to also check for the application risk profile. So again, it's embedded within your general internet access policies now. So we made it fairly seamless from that perspective. And the last thing I want to do before we close out this portion, we go into the demo, is for those of you that have already invested in enterprise DLP solutions that give you some level of visibility into data and application usage, you now have the ability to leverage Secure ICAP to be able to sync between the policies and the identifiers and the classifications from Secure Access, and then leverage that inside of your enterprise DLP. So if you have Symantec or another enterprise DLP solution, you can now use these in conjunction to be able to share and sync between the two products. So if you're in a point where you're trying to phase out from on-prem DLP to cloud DLP, this is one of the use cases for that. All right? So I'm going to jump into the first demo here, which is around application discovery and how we go about creating a general workflow and understanding general application usage. So this is the Secure Access dashboard. We're going to go into app discovery. Again, this might look a little bit familiar to some of you that are actively using it. But we show a few different key things here. The first one is every single application that's discovered by the product is shown as an unreviewed app, and then you can tag it to be reviewed, under audit, not approved, approved. And then we also have this capability of discovering high risk to medium high risk applications called flagged categories to show you, look, based on your security posture and what your organization is accessing from a user perspective, generative AI and anonymizers, et cetera, should be flagged because they're high risk and you may want to investigate. And now what we're showing here is because we have the ability to ingest different log types, we can toggle between DNS firewall and SWG. And then we can also filter by the specific types of risk. So you can see our risk categories here. Now, if I wanted to dig into a specific application that's high risk and understand more about whether I should allow it or not, so I have high risk here, I'll filter that, and then I'll look at a collaboration application. So pretty benign on its face, but if we dig into this, we can see that across my organization, that Telegram is ranked as a high-risk application. And this is the overall view that you'll now get with this application and some of the controls we can do that I'll show in a little bit. But essentially what we're showing here is your overall risk detail to show you how we came up with that score. So this didn't come out of thin air. We have a number of different attributes across a number of different criteria that we look at. So the first one is business risk. How is this application used? Telegram is, somewhere in between personal and business. What's the web reputation? Obviously, it's very poor for this particular application. And then also, if we dial down into usage risk, how is the data stored? And then we also look at traffic patterns based on organizations of your size and similar customers. How do we see the volume of traffic compared to a customer out in the field, right? We obviously don't expose that data to anyone, but we give you sort of a general view. And then does this application, or vendor specifically, report back compliance? So especially if you have locations in the EU or other regions where certification and compliance is very important, like GDPR, then we'll show you a sort of a breakdown of how compliant that specific vendor is. And then obviously the identities that are attributed to this application, who's accessed it, when did they access it, and what's the username. So if you need to track down users on access an application, you can. This is a newer view that we introduced, which is called app attributes, where we can dig a little bit further into some of these attributes that I showed earlier, like compliance. Now we include things like data security. What type of data security does this application support? Does it have any auditability? Does it have basic email authenticity like DMARC or SPF? And access control, does it support things like SSO or MFA, which are become extremely important from a data security standpoint, right? So if we go back into risk details, just another note about this application is that it's flagged as elevated risk. And the reason is that Talos, who is the Cisco security research team, saw that there's a lot of poor reputation and a lot of malicious content that's traversed over Telegram, which is why we ranked it low. And the last thing we can do here is now, if we want to outright block this application, we'll simply add it to an application list that's already attached to an access policy. So we're making it very easy for you to go in, identify the application, understand the risk, and then control that application and attach it right away to an application policy. Like I mentioned before, you now have the ability to take that risk profile and then do the inverse, which is go to the access policy first and then do it that way. And this is just showing an example of the ability to change the risk score over time that we talked about in the earlier slides. Cool. So that was around discovery and trying to understand what your overall risk profile is and your risk appetite is for having some of these applications be accessed. The next thing we'll talk about is how do you go about controlling applications, not just allow or block or warn, but how do we do that at a more granular level? So this is a feature that a lot of our enterprise customers talk about is, I may want to allow certain applications to be accessed, like Gmail, Dropbox, file send, right? But I want to take a little bit more granular control, like prevent posting, but allow sharing, or prevent upload, but allow download, et cetera. So essentially what we can do is implement what we call advanced application controls inside of Secure Access for those applications that give us that second level of control. So what this would look like in practice is the ability to do this for single applications, but also application categories inside of access policy. So we're not in any separate kind of view here. This is simply the main access policies dashboard for Secure Access. If I edit this rule up for restricted application access, I can see how it's built. So obviously we see a number of different pieces of information here. The action that we've applied for this particular application, the source, who's allowed to access this application, and what level of enforcement do we want to apply, and then also the specific application itself. So if I type in Gmail, for example, it's a pretty commonly used webmail application, I can see the little info option that gives me what controls are available specifically for Gmail. So I can then go, so this one you're preventing blocking attachment uploads. And then you can see this sort of option here where we can go in and further see what's available. For those options that are not supported, you'll just see sort of grayed out. So this is a standard view you'll get with most of the applications. If the action isn't supported, then you'll see it grayed out, and you can only select, in this case, uploads. Again, we're not even looking at anything related to data protection right now. We're simply saying, if I decide that an application is too risky or is in a gray area where I may want to allow it, then I can take an additional step to prevent users from moving files across those applications, right? That's what the options were built for. So that's essentially what we're going to be doing from that workflow. It's that simple. It doesn't take a ton of time to set up. And if we look at what the end user experience looks like once that happens, so the user is trying to compose a message in Gmail, they're going to go and click on the username or the sender that they want to send it to, and we'll just pick any file. There's actually no relevance to what's in this file because you'll see in a second here that will essentially block this file from being attached. Now, that may look scary or confusing to a user because we didn't really show a pop-up, but just know that for any violation, we are building in sort of end user notifications. So we already have that inside of DLP today that I'll show in a little bit. But we do have the ability to try to notify the user if they've been blocked. For certain content, we may not be able to present a block page or because we can't render it inside of like a Gmail sub window. So just keep that in mind that users, that may come up inside of this as you're building out these workflows that users may see like documents are not able to be attached. And what we're showing here is just that second level of view from a reporting standpoint. So I went ahead and found exactly what the offending application was, what the action was, and then you can see on the right-hand side that I highlighted, the specific action that was blocked was attach uploads. So it's not just blocking Gmail, it's looking at a very specific action that we're taking, that we were enforcing inside of Secure Access, okay? So this is sort of both sides, what the admin sees, what the user sees, and sort of the interaction between the two. All right, so let's get into DLP. And obviously, we talked about the application protection side. How do we go about discovering, reining in application access? Now we're talking about for those applications that you are deciding to allow or have sanctioned applications like a Microsoft 365, what steps are available or what capabilities are available inside of Secure Access and what steps can you take as an admin to start build policy. So as I mentioned, there's two modes of DLP that we support today. One is called API-based and one is called out-of-band, inline. API-based is just that, where we will add ourselves as a super or authorized user inside of that application. So you'll onboard a ServiceNow or your Slack instance or your Microsoft 365 instance, and we'll start streaming in event APIs from that application. Anytime a user changes a file, moves a file, changes file permissions, shares it with someone, or if that file is violating DLP policy in any way, we'll report that immediately. So it gives us a super deep level of visibility than just doing like proxy-based DLP. Now, next question is, well, what's the point of proxy-based DLP? And that's the main sort of use case here is we can go very wide. So this is where it's for a limited amount of applications because you have to onboard every app. Inline proxy-based DLP is wide, and the benefit happens in real time. This is API-based. There's a few seconds where we'll have to process the APIs and then take an action. This is real-time proxy-based DLP. So for those critical applications that you need immediate access and block access right away, inline DLP is what we usually recommend for customers to deploy because it happens in real time, it's based off of our proxy, and it has wide coverage. It really supports literally any web destination and any web application. So we don't even have sort of a limitation on what you can do. As long as you can input, download, share, move data around inside of a web application, we can support that with our inline DLP. And this is just sort of the core pillars of what we call multi-mode DLP. It's really around detecting, putting in guardrails to prevent, giving you the ability to discover sensitive data by doing an incremental scan of your Microsoft 365s and Google Drives, and then taking some action to remediate. Whether remediate means block right away or it means quarantine or change file share permissions. That's what we offer. So this is just a snapshot of our inline DLP and some of the capabilities that we offer. As I mentioned, it's built off of this proxy engine that we built. Obviously, that includes requirements for things like TLS decryption And then we also have introduced over 1,200 plus pre-built identifiers. So think of things like credit card numbers, passport numbers, social security, things like that. And then giving you the ability to apply granular and flexible DLP policy, which includes obviously reporting. SaaS API uses the same classifications. You don't have to have separate classifications for inline and for SaaS. And then we also have the ability to do things like remediation actions that are specific to SaaS, like monitor, quarantine, which I have an example of that I'll show, and then revoke file share. The other thing that isn't thought about, or we have to kind of talk through with a lot of folks, is exposure. So exposure is how that file is currently being shared and what are the permissions for that file. This is extremely important when you think about, you have thousands, maybe millions of files that are moving around in large-scale environments. How many of those are maybe shared publicly, right? You might have a user that's just flipping the flag and saying, just copy this link and share with whoever. One of the things that we used to do when we introduced this is start typing in company name .docx.pdf and see what comes up for customers, right? You'd be surprised how many sort of plain file names come up when they're supposed to be shared privately that are open to the internet because that copy link was shared to public instead of share with collaborators or share privately. So discovering the level of exposure you have for each individual file is extremely important. It's not directly related to data loss, but it could be potential IP leakage or harm to your company if someone comes across that. So that's also one of the key unique things that we implemented as a part of our out-of-band use case. So here's an example of what this would look like for an end user when we have a policy attached for out-of-band. And you can see here that what I'm doing is uploading a couple documents here inside of my sanctioned Google environment. So pretty sort of benign activity that we're doing. But just keep in mind that we do have some credit card numbers that are in those documents. So if we look at the pre-built policies that we have here, we have one for PII and PCI. Credit card numbers would be covered under PCI, but those documents may include addresses, usernames, things like that. And then we'll show you the platforms that we've onboarded already. So you might have a larger list than this where you have Slack and ServiceNow and whatever. And then you have the ability to also get to a granular level from a user perspective. So do you want to include specific users in this policy? Do you want to exclude users? And this is what I just talked about, where you can set the exposure. So this policy could say, show me all of the files inside of Google Drive that are shared publicly. And it will do an incremental scan over time and then basically show you the results of that, and you can decide whether to take action. Obviously, for SaaS API, we have a couple of different options here: monitor, quarantine, revoke access that I talked about. For this one, we can choose quarantine. I'll show you what a quarantine file and quarantine action looks like for a specific file inside of a user environment. We can also choose revoke access and then get to the granular level of deciding how you want to revoke access for a subset of users that own files or for a specific file type itself. And then, as I mentioned, we have the ability to notify users today via email, so they're not sort of left in the dark in terms of, why can't I share this file? Or why did my file disappear all of a sudden and now I have this weird message about something being quarantined? So we'll make sure we provide feedback back to the user. Now, if we look at the activity that was triggered from our Google, our Google Drive upload that we just did, we can see from a monitoring perspective that obviously we had it set to monitor. We're not doing anything with it yet. The application's Google Drive, severity is high. And from a security perspective, we also obfuscate that data, which means that even as an admin, you won't be able to see the full credit card number from a security standpoint, right? This is extremely important when we talk about data security. We don't want our HR users potentially to have data to financial data inside of our environment. Just know that we are working on things like advanced RBAC, so you have separate data protection or data security users versus HR, because you have different personas that may need different levels of access to data and to DLP violations, right? It may just be DLP, it may be offensive language or whatever. All right, so this is essentially going back to the user. After the file's been quarantined, this is the original location of that file, and they'll see a message that says, hey, this file contains sensitive data. So as an admin, I can go back in the console, access the original location of that file that's been quarantined. And for every quarantined file, the file's put into a quarantine folder, and then I can view the original contents of that file. And then from there, as an admin, I can decide, what do I want to delete it? Do I want to change the share permissions? What we saw from the user side is called a tombstone file. So that's very common when you're quarantining something, where we'll place a tombstone in the original location of where that file was. So that file essentially exists in a different place, but we're not changing the path for where it is. So users know where to access it. We're not sort of removing files actively, but we're basically shifting it to another folder and then placing a tombstone in its place. So that's what you saw from the user perspective. Just note that that all can be done automatically. So we can just set a policy to say, for any document that's shared publicly that includes credit card numbers inside of Google Drive, I want to quarantine every single one of those files, and then your admins for those repositories will go in and decide what to do with those files after that, okay? So we talked about the different levels of classifications. Again, we have 1,200 plus different types of identifiers. The additional thing you can do, and this is highly asked for from a lot of our customers, is I'm a manufacturer, or I'm healthcare, or I'm the DMV of California, right? And we have a specific data set that we work with every single time. Think of tax brokerages, right? They have a 1099 form that they fill, or 1040 form that they fill out every year. The use case for exact data matching is what we're showing here, is the ability to take a fingerprint of that data set or form and use that as a classification, which means anytime someone's sharing a DMV form or a tax form, and we find it through our scans, then we want to take some action on it, or at least monitor it, scan it, and then we can take action on it. So it's taking a very specific data set, taking a fingerprint, and then using that as a data identifier. And the next thing we also provided is the ability to do that at a individual document level, which we call document fingerprinting, which is also supported in the product now. So this is more about taking sensitive or unstructured data, taking a fingerprint of that. So let's say your company works with a specific employee ID, and that's in every single document. Then you may want to take a fingerprint of that and use that as part of your DLP scans as well to make sure those employee IDs are not leaking out or doing anything else or moving anywhere else. Another capability we introduced in DLP is OCR, and I'll show some examples of how this works. This is optical character recognition. So if someone is trying to exfiltrate data outside of your environment by taking a screenshot with their phone of a confidential document and then uploading that into their personal Google Drive or Gmail, without this, we wouldn't be able to do that. So what we're doing is we're using machine learning to be able to inspect images, and if there's text on those images, we will scan it, and then we will apply DLP policy where it's needed, right? This has been a huge ask from a lot of our customers, especially those that work with a lot of paper documents, right? I talked about tax brokerages, financial data, financial organizations, health organizations where doctors signing tons of signatures on documents. This is extremely important, and it's supported across all of our different capabilities around DLP. And I'll show an example right now, actually, of what that looks like. So I have a document that I took with my iPhone of a printed out document. There's let's say a fictitious company is about to acquire another company, and I want to exfiltrate that and leak that out to the media, right? So you can see here that there's a matching, or you don't know that yet, but we've set up a policy to basically match on a specific set of keywords. This could be like confidential or Cisco internal only for our case, right? Something like that. And then we can set up a dictionary keyword as an identifier, and if that keyword exists inside of an OC or inside of a document, and the document tries to be uploaded or to any repository, then we can block it, right? And this would work with your standard classifications as well, like credit card numbers I mentioned, PII, PCI, whatever. So you can see here that we weren't able to upload that document, and as we look at the reports, we can see it was blocked I have a generic rule I created for this called OCR rule. That rule could have been anything. But we can see the file name, obviously who the identity was, who the user was, what type of repository it was, and then also you can see that the match here is for internal only because I set up a custom dictionary in my policy to say any document that is matching the word or phrase internal only, I want you to enforce that and prevent users from sharing those files. So that's exactly what was matched for that, okay? And then if we look in the OCR rule itself, the one that I created to trigger all of this, we can see the specific data classification, and then we can see the dictionary that's being created specifically for this. We do support regular expression. Yep, question?
So, like on some of those others, the user gets a notice that it's blocked by tell them why. In this case, where you're doing the OCR, you probably don't want to tell them how it was blocked.
Yeah, so the requirement for setting up notifications is not mandatory, so it can be optional. So if you have specific things that you're doing for like an OCR policy, you don't have to set notifications for that, right? So that's a good call out. The question was, we may not want to notify our users that may be trying to exfiltrate in this way that, hey, you violated DLP policy, right? Because we want to be able to monitor that. So that is something that there's no requirement for notifications. You can toggle it on or off. Yep, go ahead.
So I saw you support like 1,200 classifiers.
Yep.
But how many are AI ML-based classifiers does Cisco's DLP support?
So the majority have some level of AI and ML. I'll actually talk about when we go through our generative AI section. There's a number of things that we do that are specifically only AI and ML built. Obviously, we have a team of researchers, but a lot of that is built. OCR is obviously used as a lot of ML to be able to scan and check for different identifiers. All right, so now that's a good segue into understanding or providing a pathway for users to access applications and use applications, but taking almost a guardrail or a bubble around that user as they're trying to use applications. And one of the ways we do that is through browser isolation. So for those of you that aren't as familiar or you sort of heard about browser isolation, essentially what it does is takes a carbon copy of a web destination, presents it by pixel, what's called pixel streaming, we'll stream it back, and then we'll also do a combination of pixel streaming, plus we'll restack essentially the HTML code that the site was built off of, but remove anything that could be potentially harmful or malicious that would enter back inside of your environment. And by the way, one of the things that we do at Cisco versus some other vendors that support browser isolation, we don't require you to have a separate browser or even have a separate tab for this, right? As soon as we identify the destination and it needs to be isolated, we'll isolate it within the same session, the same tab that the user's already in. So why are we talking about isolation when it comes to DLP? Is we now have the ability to inspect inside of an isolated window and be able to apply DLP policy for that. And this is just a snapshot of the way that it generally your traffic will flow for your users. They have a web browser, whether it's mobile device, web browser, laptop. It'll go through our proxy engine and then also go through file inspection. That's another key thing about our isolation engine. It's not just isolating, it's not just applying DLP. We also do full file inspection. So if a user is trying to download a file that could be potentially malicious, we'll download that. We'll actually scan it, go through our engine, and then it will be isolated from that point forward. All right. So let's look at a combination of what DLP and RBI looks like right now. So if we look through our policy engine, and then I'll show the end user experience of what this would look like. You want an end user is in an isolated session and is going through DLP. So if we pop this open, one of the other things that we've done in Secure Access is we always have this idea around unified policy, but also intent-based policy and try to simplify that. And one of the things we've done is introduce isolate as just an option. So we have allow, block, warn. Isolate is simply a button check. And then from there, you can identify which destinations you want to isolate. So in this case, in this example, what I'm going to do is just choose a cloud storage, publicly available cloud storage application called ForShared. doesn't require a login, and this is one of the ways that your users could circumvent and exfiltrate data, right? Maybe they're taking it from a public, a private repository that contains PII or IP, and shove that into something like ForShared and give a link to someone that they're trying to share with, right? So in that sense, these kind of open source, publicly available collaboration tools sometimes make it very difficult to track exfiltration events, and this is one of the ways you can prevent that. Pastebin is another example, right, where you can simply just add in stuff and share it with someone. So this is just going through and showing you the examples of how the DLP classifications were set up. Obviously, we have a select destination for this example where we're choosing ForShared. And then from a user perspective, I'm going to go and open up the ForShared web application. Again, it's a public site. You don't need to log in for this. And I'll point out a couple of different things once we see how it's isolated. So it's going to open up. There really wasn't real time. I didn't speed this up for this recorded demo. The only indication for the end user is this little box here on the bottom right that says that the page has been isolated. So that is one sort of requirement that we have this sort of window, little mini window or icon that shows that it's been isolated. But other than that, this is exactly how it would look to the end user if they weren't isolated. So we can see that I'm trying to upload a file, and you notice that the user gets a message back from Cisco, a notification that, hey, we weren't able to upload this file, and you violated DLP policy. So this is one way where we can give the user an immediate pop-up that says, look, you've tried to do something in an unsanctioned application, or you violated some DLP policy by your company, and then we need to take sort of the next step or next action. And then, so what we'll show from a reporting standpoint, just real quick, is what that looks like. This is the general activity search for Cisco Secure Access, not DLP, which will be able to show you every single session that was isolated and the action that we took for that. So you can see here as we're scrolling through to the right here. So it was allowed, obviously, but it was isolated, and then what the content type was. And then if we go into DLP, we can see the policy that was actually triggered. So there's two policies triggered here. There's an isolation policy, and there was a DLP policy that was triggered. So we can see quickly the results of the DLP policy. I use the same document that I used in the other OCR example just to show you that even within the isolated session, we can still do optical character recognition. All right, so I'm going to close this off by talking about something top of mind. I don't think I'm going to go through the first section because I think at this point, everyone either understands what generative AI is or is scared of it or is excited by it, but I think everyone in this room has a general idea of what it is, how people are using it. I don't know if you've seen the Google VO3 stuff yet, but they added like AI can talk now, which is very weird. So anyway, that's another conversation. But let's focus on these two, right? What is the inherent risk involved in allowing generative AI to be used in your environment? And there's definitely some risk involved. And then how can you provide safe usage? So when I talk to customers, generative AI is like, oh, wow, yeah, it's great you guys are doing things, but usually the answer is one of two for a lot of our customers is what is your posture around generative AI? Most customers will say either we just block it, we don't allow anything, or we don't have a policy at all. The latter seems to be more true where organizations just don't really know what to do yet. And they're looking to Cisco to say, look, help me understand the risk and what I should be doing to kind of rein in this generative AI usage. And just to give you an example, so when I did this session, I think last year, it's 2024, we had a list of about 80 generative AI tools, not because we were behind. That's just, there weren't a ton. 80 is still a fairly large number. Now, that list has grown to 1,200, I think 1,300 plus, and growing every day, right? So the amount of generative AI tools that are being built on a daily basis is exponential. So if you guys have time to go out to the demo booth, talk to the AI defense guys, and they'll tell you how many of these apps are being developed every day, and it's becoming sort of spreading like wildfire in terms of usage, right? So that's just my sort of spiel on like, could be a potential problem. It's a vector for data exfiltration, but it's also a vector for a lot of other nasty stuff that I'll give some examples of. So we've implemented, to that point, we've implemented a way to provide safe usage for generative AI. That includes using the same data classifications that I talked about, and then being able to leverage that inside of your specific generative AI tool. So if you're allowing things like ChatGPT or Gemini or Microsoft Copilot, you can do that in a fairly safe way, but still have some guardrails from a data loss perspective standpoint, right? Where we can block something like source code from leaking out into outside of your organization, right? So I'm going to give you a couple examples on why you might want to have a policy for generative AI. The first one is the early days of ChatGPT. There was a large, I think I can mention it. There's a large Korean telecom. Okay, you can figure out who it was. All right, and they had 2 developers that were using ChatGPT to verify and check source code work. So they were responsible for building out source code inside of their mobile devices. And they said, look, ChatGPT gives us the ability to check source code and say this snippet of the code is incorrect. Here's what we suggest. So they're literally putting their confidential source code into OpenAI ChatGPT and getting it to check work. And as soon as they were caught, the company's stance was, we're just going to block everything, right? So this was one example. Again, this was early days, but as I mentioned, I still talk to customers today where they're like, we don't really have a posture or anything around generative AI. We just let people use it however we want. So that's one example where with better policies and controls, they could have monitored this event, got triggered for a potential DLP violation, and then talked to the users or whatever the remediation was. Another example is a law firm for an ongoing lawsuit against an airline for personal injury. It was either, I can't remember if it's an attorney or like a paralegal that basically created a 10-page briefing to support the plaintiff's case. And they found out that there's a ton of things that were incorrect in the legal briefing. It was referencing cases as part of the legal briefing that didn't even exist. It was making up case names and things like this, right? And obviously that's like malpractice, first of all. But that's an issue because this was an ongoing trial and they're preparing for an ongoing trial. You have things like fraud, obviously reputational issues, embarrassment, reputational damage. So there's that aspect of it too. It's not just data leakage sometimes. It's like, are you using this in the right way and do you trust the data that you're getting back? And I actually have some really cool things that we're doing with the AI defense team that I mentioned around putting in guardrails for this example, but also we have some ways on doing that for data leakage. So this is a hot off the press capability that we introduced in Secure Access called AI Access. And you'll see it in our dashboard called AI Guardrails. And across the board, you can see that we are focusing on a few different things. First of all, security. So every single one of these applications have guardrails built in. Like you can't just go to Copilot and ask it, build me a bomb, right? Or how do I build make a 3D printed gun? They've already built in those guardrails in place. But there's ways to get around that. So there's a technique called prompt injection, where you can get the AI, essentially tricking the AI by either asking it, repetitive things or asking it to craft you a story, a fictional story, in order to get the data that you need. Because these LLMs are scraping the internet. They inherently have this data, but there's guardrails in place so they don't give out that data to users, right? So one recent example is the Trump Tower bombing that happened in Las Vegas, the Cybertruck bombing. The attacker basically used a method of prompt injection and got instructions on how to build a car bomb from ChatGPT. That's violating, obviously, ChatGPT's terms of service. And I'm not saying your users out there are going to go and do this, but it's an extreme example, but it shows what can be done if you have a user that's dedicated and sophisticated enough to do something like this, right? So that's security. We can do a number of different things here around detecting, cybersecurity, hacking. Privacy is pretty in line with, traditional data loss prevention. But then safety and relevancy are things like, is the user trying to ask about, financial harm or even self-harm? And that we can do some relevancy checks as well to see, is there like content moderation? Is the generative AI tool hallucinating, for example, and giving false answers, things like that, right? And this is what it looks like now. So you'll see in the dropdown inside of Secure Access, we have real-time SaaS API, and then we have our AI guardrails as another option to build policy off of. And then those individual categories that I showed before will just be selectable, and then you can obviously select the individual identifiers that you might be interested in and create your own custom set of identifiers, right? Maybe you want one for prompt injection, and you want to pair that with something around reputational harm, et cetera. You can kind of custom build that as you go. And this is just a snapshot of some of the identifiers, not identifiers, some of the objects that we found as we're started to pull out some of the offending, DLP violations for guardrails, right, across privacy, security, safety. So again, newer capability. We do have a demo of this in the Secure Access in the demo stations. If you guys want to take a look, I would say if this is all interesting, if it's kind of spooking you a little bit, definitely come and take a look. So with that, I did want to give take a one step back and give a quick example of one of the things we can do around DLP and generative AI. So I'm using ChatGPT in this example, and I'm going to plug in, just a sort of benign thing about, hey, what is Cisco Live, right? So I thank it, and then now I check, hey, can you please check a piece of source code for errors? This isn't inherently built into guardrails, right? I'm not doing anything malicious at this point or anything weird. But if I were to put in, let's say, my custom intellectual property source code, like those Korean telecom developers did, then I get a notification from ChatGPT that there's an error. Again, like I mentioned, because this was a DLP violation, I can set up notifications to let the user know that the reason they were blocked or they see an error is because of a specific DLP violation. And then we can see the example here where we're showing the user, or showing the admin, the snippet of source code that we identified. So we can identify, I think, up to 10 to 12 different languages now, C++, Python, et cetera, and then be able to detect that and take action, right? As we're going through, one other thing I did want to mention that I forgot around the AI guardrails is that we have the ability to inspect not just the response, but the prompt as well. So as the user's putting in the prompt, we'll block it that way. And then also if there's a response back from the generative AI tool, we'll block it there as well. So it's going to happen on both levels, right? And this is just an example showing what's inside of our current source code identifier, what languages we're checking for, et cetera. All right? So we went through a lot of stuff today: application usage, discovery, risk assessment, DLP, generative AI guardrails. The last thing I wanted to talk through is once you sort of have your posture, your policies in place, you know what you're doing with DLP and application usage, what about the existing files inside of your repositories? So one of the capabilities we have is called Cloud Malware, which is a separate dashboard, but it will show you a full view of every single file that lives inside of your different, storage collaboration tools, and then how many of those files are malicious. So we're actively scanning these through our AV engines to see if there's anything malicious inside of your repository. And you can take the same actions as you did with SaaS API. You can quarantine, revoke, you can, in some cases, you can delete. So we do have the option of delete for using webhooks inside of WebEx Teams. So there's a couple of different options you have in terms of remediation. You can also manually remediate as well to say, look, I'm going to close off this entire folder, right? This is just showing the remediation options that I talked through. Obviously, this is one thing where a lot of our customers don't think about, like, hey, I have files, I inherently trust them. They're in my secure repository. But if you're working with contractors or collaborating with a lot of different vendors, they may be sticking stuff inside of your OneDrive or SharePoint that you may not be aware of, right? So it's important to understand it from that level. The last thing I wanted to talk about before we wrap up is sort of on the note around unauthorized access or malicious access is this concept of third-party applications or micro-applications. So you have users that are on 365, that are using Google Drive, that are using Slack, whatever. Generally, if you have power users or authorized users, you don't have a security posture profile today around this, I can go in as a user and install like some weird PDF scanner, right? Because my company doesn't have Acrobat Adobe, but my company does have, let's say, Google Drive, and it has, I searched it, typed in the Google Store PDF scanner. It's not Acrobat, it's some weird third-party PDF scanner. The inherent risk is that PDF scanner not only will potentially scan my data and maybe take a copy and who knows where it lives now, but also it has different levels of what we call access scopes. So some applications can act on behalf of a user. It can scrape user data like address, name, phone number. So there's an inherent, it may not be specifically related to data loss, but there's an inherent risk of exposing this type of data, right, personal data, or being able to email on behalf of a user, things like that. So we want to rein in that access. So what we do is, as you're onboarding your Microsoft 365 and your Google Drive and your Slack and ServiceNow, we'll basically scrape through and we'll do an incremental scan and show you which applications have been installed inside of those environments, what the access scopes are, and then you can immediately revoke that token. So this works based on OAuth, and there's basically a token exchange that happens to trust that application. We'll revoke that token, and then from that point forward, we'll also prevent anyone from ever installing this application. So we've essentially closed off access. So it's a newer capability, newer dashboard that we introduced, but keep in mind that it could be potentially powerful and it might show you exactly what's installed, right? Not just your main application that you care about, but also these kind of micro applications that live inside of Microsoft and Google, all right? Cool. So I'm gonna wrap up, and mainly just to kind of summarize everything we talked about today, right? We obviously started with visibility, giving and enabling your admins and your teams to discover application usage, assess your risk, and then take the next step of controlling access. Once you understand where your risk tolerance is and where your risk limit is, and then going one layer deeper into your existing applications that you are in charge of, that you sanction, providing data protection, and then that includes now, obviously, from an generative AI perspective, and then file monitoring, which is that continuous monitoring of third-party applications, but also malicious files as well. All right? So with that, I'm probably not the first person to say this today, but it is extremely important for us as we wrap up that you guys fill out the surveys. Feedback is always welcome, and I think there is sort of some gamification built in where if you complete a minimum of 4 surveys, you're in a drawing to win passes for next Cisco Live. And then please continue your education. As I mentioned, we have a ton of demo booths related to this topic, but also AI and lots of other great security topics out there. So visit us at the showcase. If you want to meet with me or any of my peers directly, you can set up an MTE anytime this week. I'm here through Thursday. And then, the CTF's walk-in labs, tons of great content for you guys. And then I understood that the sessions, the PowerPoints might not be available today, but definitely they'll be available on demand with the recording of this. All right? So that's my time. Thanks, everyone, for attending. Thank you. If you guys have any questions, I have a couple minutes. I'll stay on for a little bit.